That's a long video.
This is going to be a long video. Right. Okay. So what we're going to be starting with is vectors and scalars. We are actually going to see vectors and scalars in Chapter 3, but we have to talk about them now because as you look at our kind of board back there, you can see today we're looking at distance, displacement. Tomorrow we're going to talk about speed, velocity, acceleration. So those are all actually going to fit in here. What's going to happen here is we're actually going to write down our definitions for vectors and our definition for scalar. So the easiest place to start is, how many of you know what a vector is? How many of you have seen the movie Despicable Me?
Yes.
Okay. If you've seen the movie Despicable Me, you know what a vector is.
Oh, it's the evil villain.
It is the evil villain, yes, but he actually gives the definition of what a vector is. Anyone remember?
No.
It's when he introduces himself. He's like, "Hi, I'm Vector. I commit crimes of both."
Large and
Well, not large and small. Anybody remember it? No?
You should play it.
I would, yeah, I actually should take that clip. I have the video, but I just didn't bring it in. So vectors are something, he says, that I commit crimes of both magnitude, or of direction and magnitude. He's like, oh yeah. That's what he does, this like thrust pumping thing. Okay, so vectors, basically what we are going to have here is that they have a magnitude and a direction. Okay, so you guys know what they are now, right? No? You still can't figure it out? So if I was to say, what's an example of a vector? Would you be able to give me an example? No? All right, so how about we break down the definition a little bit more? How many of you know what a direction is? How many of you know what a magnitude is? Okay, so what's a magnitude?
like an intensity or something?
Yeah, that could be. A magnitude could be like an intensity. Let's make it simpler, though. What is a magnitude?
The amount of something.
Perfect. Okay, so magnitude is an amount, a number, a value, a quantity, right? So it's just whatever you are figuring out. It's how much. So when you're looking at magnitude, if you wanted to jot that little thing into your notes, magnitude is the amount, the number, the quantity, the value, how much. That way you know what the definition of magnitude is, because otherwise, if you're looking at a definition for a term and you have no idea what it still means, then you probably want to define something else that's in the term itself. Has that ever happened to anybody in, say, an English class or something? Or social studies, where you're like looking up glossary terms, you're like, I don't know what I just wrote, right? And so you got to look up those terms again.
So is an example like miles per hour?
Well, that's a unit, and that could be a magnitude. We'll talk about a couple of them in just a second. All right, scalars, on the other hand, are just scalars. You're like, yeah. But what is a scalar? Take a guess. It's not going to have a magnitude and direction. What will it have? You don't know? It's going to have a magnitude, but if I'm putting a but in there, what does that mean?
It's not just. No.
But it has no direction. So right now, you guys in this class, and those that are not in this class, since we're missing 8,000 people, you guys are all scalars in terms of physics. You have magnitude. You have something there, right? You have some knowledge, but you have no direction. But after this class, you guys are going to be vectors, and you're going to have a direction because your direction is going to be now that you are all going to be physics majors in a post-secondary education.
That's awesome.
Right?
Yes.
You guys like me?
Yes. Yes.
Okay. So let's look at some examples then. Things that have a magnitude or like a number, but you also require a direction, and things that don't need a direction but have a magnitude. So what do we got? Something that we would measure in, say, the lab. What did we measure in the lab? What did we do? Measured water, right? So the volume, good. So volume, do you need a direction for volume? That's the distinction. Do we need to say, oh, that was 35 milliliters north? Nope. So that makes it a scalar. So we could say volume is a scalar. Along with volume, let's throw an area because it's very similar. How about mass? Do you need a direction for mass? Nope. How about temperature? What would you say about temperature? Would I hear the weathercast, or not the weathercast, the forecast, and as I'm listening to it, they're going to be like, outside today it's 57 degrees Fahrenheit. Are they going to finish it with north, south, east, west, something like that? No, they're just going to drop it right there. 57 degrees Fahrenheit. So temperature is a scalar. Because these are all values that I don't need a direction. You're just going to measure that quantity, and that's what it is. All right, now to get into some of the ones we're going to talk about today. Yeah?
What about measuring the
Heat. Heat is actually a scalar as well. It's a form of energy. It's not about heat rising. That is just the trend of a change in heat. So changes can be positive or negative, but the value itself is always going to be positive. All right. So the two terms that we're talking about today, distance and displacement. They are very similar, but they are different. So which one is going to be a vector? Which one is going to be a scalar?
between distance?
Distance and displacement.
Distance is going to be a vector.
So you say distance a vector. Anyone else agree? Yeah? Okay. So if I said measure your distance in here, then I'd be going like this, right? And could you measure my distance if I went like this still? And I went like this. Could you measure the distance I'm traveling?
Yes.
Yeah.
It's called a pedometer, right?
Yes.
Put a pedometer on your hip, and you can walk around wherever you want, and it's going to measure every single step if it's good. So distance, no, it doesn't. It doesn't depend on the direction. So distance is a scalar. Because all I want to know for distance is how far did you go? What distance did you travel, right? Displacement is the one that actually requires a direction. So we're going to add displacement. This will be our first vector. So displacement is something that has a magnitude and a direction. I'll give you a difference between these two. All right. After school, how many people are staying here after school today for whatever reason? Okay. How many are going to go eat after school?
Yeah.
Okay, let's say you're going to go eat down the road. Subway's that way. Chinese, whatever else is that way, right? Which way are you going to go?
I'm gonna go left. I'm gonna go to Subway.
You're going to go to Subway? All right. So let's say you're walking down to Subway. It's about quarter of a mile. So as you're walking down to Subway, I could say that your distance traveled is a quarter mile. So I could say, all right, after school, go walk a quarter mile. That's a distance. Displacement, on the other hand, I'm going to say go walk a quarter mile southeast.
Why not say like take? Wait. Question.
Yeah.
Why don't you just say like take like I don't know 200 steps? I don't know something where it's not measuring distance but measuring like I don't know like you're not really measuring.
That would still be a distance.
But
Except for your
you'll
unit
know
would
the
be
distance.
steps. The unit would be steps in that case. Still a distance. It'd be the same thing as in the past, farmers used horses to plow their land, right? They didn't come up with this, unit of watts. They just called it a horsepower. Exactly. And so they used whatever they had. So it would be the same thing. If you wanted to take 200 steps, steps is your unit, but it's a unit for distance. It could also be a unit for displacement if I tell you what direction to travel and how many steps. So like Pirate's map, walk 30 paces, right? Paces, it's not really anything we can actually measure. What's a pace? Some people are going to have a bigger pace than other people.
But they'll have different steps. Somebody will have a different.
Right, so that's what makes treasure maps hard to do because you don't exactly know what a pace is. Person who measured it out could have been really short and then their paces are like this. Or if they're really tall and then their paces are like way out here, but you don't know, so you have to estimate that. Yeah.
Something like coordinates, like longitude, would that be displacement? Because you're saying like 40 degrees north, 40 degrees south.
I would say it's more actually a position than displacement because you're not moving it. You're not going anywhere with that latitude. It's just telling you that would be like your frame of reference is where you would want to start, and then you could move from there. So you create distances or displacements from a latitude or longitude. Cool. All right, other things. Tomorrow we're going to be looking at speed, velocity, acceleration. Where does speed, velocity, acceleration fit in?
Right.
Well, they're not all vectors. I'll tell you that.
Speed is a scale.
Speed is a scalar. Speed is a scalar. Because speed, all I'm asking is how fast are you going? So you could look down at your speedometer and be like 22 miles per hour. Right? Or
But isn't that a distance?
that's
I mean, I get it's speed. I get it. But as the speed, you're showing that you're going 22 miles, which is a distance, in 1 hour.
yes, correct. It's a rate.
Yes.
Yes. So distance is not a rate. Rates are always with respect to time. We'll talk about this tomorrow when we get with speed and velocity. But speed and velocity are rates. They're always with respect to time. So we're saying that it's a distance or displacement changing as the time goes on. That's why it's not a distance or displacement, because we're looking at how it actually changes with respect to the time.
Okay. So if you just say like, run 22 miles.
You could run it at a really slow pace, and it's going to take you a long time, or you could run it at a marathoner's pace.
Right, as long as you're doing it. So there are two different things if you put the time in there. Like
Right.
If you have to go
Yeah.
22 miles.
Then it becomes a rate, because then it's happening at a different amount of time.
I get it.
Cool. All right, so that means velocity is going to be a vector quantity. And we're going to throw acceleration in here too. We'll throw one more on the scalar side, and then we'll throw one more over here. For vectors, we're also going to add in a force. Force is an example. Your weight is actually a force, and so that would fall into a vector category. And the last one we'll add over here, since it came up, is time. Okay, so time is a scalar quantity. I don't care what direction you're traveling. You could say that I'm going to walk for 30 minutes, but the 30 minutes, it's just a measurement. You don't actually need to know which direction the 30 minutes is going to be unless you're talking about like degrees. So it just depends.
Sorry to interrupt, but can I pass out some sirens if
Sure.
anybody wants one?
That's fine.
Does anybody want a siren? Figured it. Sorry to interrupt.
It's all good. All right, so the next slide is up. Go ahead and take a look at it. It's on displacement. Once again, you can write everything on here, and we'll add in little bits here and there too.
Mr. Schmidt, did I miss a slide while I was on?
Maybe.
Kira.
Can't forget about these.
I don't know. Are we?
Uh-huh. Am I what?
I saw the yellow.
Yeah, just write it. Write it all. There's not a lot to it.
Are you gonna explain?
Absolutely.
Thank you.
Have I never?
I was just making sure. I didn't know if I was supposed to know it. I didn't know if
No, I will always explain slides. I'm not a teacher who will just put something up and then just skip to the next slide. That's just silly. as we get through an example later, we are going to add another definition for displacement. It should make it a little bit easier to recognize it, but it's easier to give that definition whenever we get to the example. So you'll see that in a little bit.
That makes sense.
All right, so the top of this, if I'm looking at the top portion of this slide, I can see it says the change in position of an object is displacement. There's going to be a little bit more to it, like I mentioned, that we're going to add. So as long as I'm looking at a change in the object's displacement, or not displacement, but their position, then I know that an object's going from one spot to another. And if I measure kind of like the straight line between them, then that's going to give me a displacement. What I want to focus on this slide is this symbol right here. So what is that symbol?
Delta.
It is. Good. And what does delta mean?
Change.
Change or change in, which means that if I had a delta symbol, then anything that follows it, for example, if I had, let's say, delta smiley face, how could I expand out delta smiley face?
Smiley and
Good. So smiley face final minus smiley face initial. It doesn't matter what follows the delta symbol. It's always going to break it up and tell you what the difference is. So final minus initial. You're going to see this delta symbol a lot in this class. And you're going to see a couple other Greek symbols or Greek letters a lot in this class. Which means that if you see this delta symbol, I do not want you to immediately think that it's a distance or displacement. That's what happens a lot. It is something that you got to be real careful with, because when you first see it, it's with delta x. So then as soon as everybody sees this delta, they're like, oh, I got delta, that's distance. But be careful. Delta just means change in, so it's just going to expand it out to a final minus initial. And I will say this every semester, and there will always be people that do the same thing. Okay? So your displacement is your final minus your initial position. It's always final minus initial, never initial minus final. Okay? Final minus initial. All right. As I'm looking at this slide, you don't have to write anything down. You can just kind of visually look at it. So if I'm looking at this situation, if I have a gecko, and let's say it's actually starting so that its head is back there. So the gecko is at the mark of 38 centimeters, and if the gecko is to travel to 88 centimeters, then what happens? What is its displacement?
50 centimeters.
50 centimeters, right?
Yeah.
88, final, minus 38, initial. Got it?
Yeah.
Okay. However, what would happen if I brought the gecko all the way back again? If I'm going to change the frame of reference. So that instead, 0 is going to correspond to my initial position. So instead, 0 is right there now. So it's like I took my 0 and I kind of scrunched in the scale. Can you visually see what I just did?
Yeah.
So the 0 was off of the slide, off to the right-hand side, but now I've pulled it in. Now if the gecko is to travel the same exact in terms of the distance that you guys see here, what is its displacement? 88. So what did I change?
The starting or the initial.
The starting and the initial by changing the what? The frame of reference. So remember that distance or displacement is always going to be measured off of a frame of reference. So you have to pick that frame of reference. The important part of this slide is sometimes your initial could be 38 centimeters. Other times your initial could be starting at 0. If that's the case, a lot of times your delta is really just going to be like your like delta x is really just going to be your whole displacement. But on occasion, if you do have an initial value, that will change things slightly. So for example, if I was giving you in a situation in chapter 4, and we're standing on top of a building, and I'm just going to throw something off the building, but I want to know what maximum height it actually rises to, then at the end, you would have to take into account that you actually started off the ground just like at the very beginning. Does that make sense? So you'd have to kind of include the fact that the height of the building is important in that situation. So sometimes your delta x is not going to be the whole total displacement or the value of what you're looking for. Okay. All right. Two things about distance displacement. This is going to basically tell you if I was giving you a word problem, this might be how I would ask for one or the other. Okay? So you can kind of jot down all of that on the slide would be important. So the two bullets at the top and even the part at the bottom. Your tests are graded, by the way. I didn't put scores on them yet. I was hoping to get other people actually here today to finish their test. I did get one, which is good. So if I have a good enough range and the scores look good, I'll go ahead and put those in Power School right after school today. So you should be able to see what your test grades are. You won't get the test back, though, until everybody has taken it. So if you're one who really cares about your grades, check after school. I would say check by 5 o'clock. Just to give me a buffer, just in case I have any random meetings at the end of the day. I don't know. I don't remember as I go through. I just kind of ignore it. That's one thing, like, when you guys are asking for grades and scores, I don't really look at who has what as I grade. Just more fun that way. The only time I ever flip back to the front is if somebody puts something weird or funny, and then I have to go back to see who actually said it.
What do you mean by good and funny?
Sometimes people leave random comments, like, "Ooh, I liked this. Good choice on this," or tell a story. "Oh, this reminded me of whenever I did this," and then people just randomly put stuff on the page.
Do you enjoy it?
Sure. A lot of times I respond if I have time.
Do we get
Which is
bonus
normally a
points?
lot. What's that?
Bonus
No, I don't get bonus points for it though. Okay,
points. Just making sure.
so the difference between distance and displacement, a lot of times if I'm asking you for a displacement, I will use the word displacement. I mean, there's really no other way to look at it, unless I said, how far are you traveling and in what direction? That would be another way I could ask for displacement. Because then really I'm asking for your magnitude and your direction. Because I'm saying how far and in what direction you're traveling. When I'm asking for distance, my more or less will just be saying how far did the car travel, or I might say what is the magnitude of the displacement. Do you hear the difference there? So if I use the term magnitude and I'm asking for the magnitude of something, I just want the amount. It's actually not going to include a sign because magnitude is an absolute value. You can kind of think of it as like the hypotenuse of a triangle. It's not going to be positive or negative. It's the x and y's that will make a triangle positive or negative, never the hypotenuse. So anytime you're asking for a magnitude, just think absolute values, always positive. And I don't need a direction if I just ask for magnitude. All right, at the bottom you can say, or you can see that I said, can they ever be negative? And the only one that can be negative is a displacement. And what is the reason why it can be negative? Positive and negative is a what? A direction. And what requires a direction? That we just learned. Which is a version of a vector. Exactly, good. So the reason why is you can say it is a vector. And if it's a vector, that tells me that it requires both a magnitude and a direction. And if it has a negative direction, so be it. That is a direction. There are different ways I can give you direction. I can say positive or negative. I could say left and right. I could say east and west. So there are 3 different ways, or 3 main ways that we can look at for giving a direction. All right, we are almost there. Cardinal directions. How many know their cardinal directions? How many do not know their cardinal directions?
Like north, south.
Yes. How many like to mix up east and west?
No.
Isn't that fun?
It's we.
To we.
Steve.
Okay, so anyways, what is this?
North, south,
South.
east,
East.
west.
I knew that.
You knew
northwest,
that?
northeast.
Yeah, I didn't know.
All
if
right,
you meant like
we're going to
something
simplify things for this chapter. Next chapter, we're going to make this a little more
fun.
complicated.
Oh, don't do that. Never eat.
But I will. Yes, true. Or I don't know why people. I actually like soggy waffles though.
South.
Yeah.
Sogged in with butter and syrup.
I'm
They're
kind of with you
good.
on that.
Yeah.
honestly.
That's totally yeah. Now toaster waffles, no thanks. All right. What is that?
Northeast,
Okay. What is that?
southwest,
What is this?
northwest,
And what is that?
southeast.
East and south.
I didn't
It's not a person. It's not funny. It's terrible. That person's gonna get made fun of for the rest of their life.
know that. Being named after
Anyway, well, they didn't have a say in it. Hopefully, they change their name or go by something different.
What? US kid or?
Okay, so like I said, in chapter 3, we're going to make this complicated. We're actually going to look at this and this angle, like say this one and this one. They're going to be completely different from each other. And then we're going to have a different way of describing and naming it.
That's fun.
It is. And so we'll do that.
What do you mean?
Northeast.
You'll find out in chapter 3.
Oh, didn't erase.
I don't want to wait.
I don't care.
Oh.
It's okay. It can stay there.
You said
That better?
That's much better.
Okay. You felt bad for me? Because
Yeah.
it just wasn't working.
Oh my
All right.
gosh.
Oh, for that.
What? You don't have to write this if you don't want to.
Mr. Scammerded.
All right, so this is an example. Like I said, on this example, I'm going to give you a better definition for what displacement is. So yes, if you were able to pronounce my name correctly, that would be beneficial. But Mr. Schmidt decides to walk a few city blocks while visiting a city. Redundancy. If all of the, I could call it redundant city. All right, if all the blocks are the same dimensions, what would be the distance and displacement of me and my walk, basically, if I first walked 3 blocks north, then 8 blocks east, then 1 block north, and finally 3 blocks west. Okay, so we're going to draw it out first because it's probably helpful to have a visual. Okay. What's that?
We're gonna start at 0.
Yes, good. So we have to pick where we're starting. I'm going to choose for you, and we're going to start right there because I'm the one that wrote it, so I know that it should stay in the grid then. Okay? So first we're going to travel where?
3 blocks, 3 blocks.
3 blocks north. So let's draw it in. 3 blocks north. Okay, then
8 blocks east.
8 blocks east. Okay. 8 blocks east.
1 block north.
1 block north.
3 blocks west.
And 3 blocks west. What was somebody saying back there?
I was just, why didn't you walk forward?
That's a great question. Because here's Bill's house. Then I had to get pizza. And then I had to go to get my nails done. And then I had to come back and
Go to Larry.
Go to grandma.
go to Larry's.
Larry's, yeah.
Larry's, all right.
Larry's.
So ultimately, yeah, Bill and I went to go get our nails done together and get the pizza. So we ate pizza while we were getting our nails done. It's good. Anyway, so you might have different locations and ways that you have to get there. My question is, what is the distance traveled? How would I find it?
15 blocks.
15 blocks, very good. So the distance, you're basically just going to say 3 plus 8 plus 1 plus 3. And you get 15 blocks. That's easy, right? Okay. Question is, how do you find displacement? We do. And here's your definition that I said I would give you. So your displacement, write this down. Your displacement is a straight line from where to where?
Initial to final.
Okay, good. Yeah, initial to final. I'm going to write start to finish. But if you want to write initial to final, that's cool because then it kind of connects in with what you wrote earlier for your displacements. So start to finish, initial to final. And by saying start to finish or initial to final, what that's telling you is you know where you're going to start drawing your arrow from and where you're going to end. And it also tells you what direction you're going to be headed. If I went finish to start, I'm in reverse of what I would want to do. So this is like, let's say we were going on a treasure hunt. And for this treasure hunt, we had to walk all those steps, and then we were able to get to our destination. Or, if you were smart, you'd be like, all right, I'm going to add all these up, and I'm going to find exactly where I need to go without having to walk all the separate steps. And you just walk one step, and then you're there. And you could beat the people, whoever were trying to travel the whole distance there. So, a lot of people are going to travel 15 blocks. What we're going to do is we're going to travel from here directly to here. Like so. Which means that I need to know what this is, and I need to know what that is. Right?
Yes.
So how far do I have to travel to there to there?
5 blocks.
5. How'd you find that? You counted it, right? But let's say you didn't have a visual there to count. How far did we go with the red arrow?
8.
How far did we go with the blue arrow?
3.
But it was 8 to the left, or sorry, to the right, and 3 to the left, which made 5 to the right. Exactly. So I know that that value for the x was 5. 5 blocks. All right. How about the y?
4.
So Shannon already said it, right? In the very beginning, you're like, why didn't you just walk 4 blocks in the beginning? Okay. So why didn't we just walk 4 blocks at the beginning? Because we had 2 separate vectors. Or let's say this was in the wilderness and there's a bunch of mountains here and this is the only way to pass through the mountains. Okay. So instead of walking, let's say I have one of those, seats you can sit in, and has like the fan, big fan behind it, and people with the parachutes, you know what I'm talking about?
Yeah.
Heard them before, they're really loud.
Mhm.
So I have one of those, so I can just go right over the city and land right there. So I can go a straight line through. And if I do that, I can see that I have a distance of 5 here, distance of 4 there, but I need to find what the hypotenuse is, and oh my goodness, what does that look like?
9.
And what do we do to solve a right triangle? Good, you guys said the equation and also what it is. So a squared plus b squared equals c squared. So on occasion, if you do have 2 dimensions like this, which we'll do a couple, but nothing extravagant for this chapter, this will be about the extent of what I do because we'll expand on it in chapter 3. So if I plug in my numbers, I would have 4 squared plus 5 squared. Could I have done 5 squared plus 4 squared? Doesn't matter, right? Commutative property of addition. I could rearrange the order. It's not going to change anything. Equals c squared, so this is going to be 41 equals c squared. So c is equal to the square root of 41, which is approximately 6.4 blocks. All right, so if this was a treasure hunt, all the other treasure goers are going to walk 15 blocks. You're only going to walk 6.4 blocks. Who's going to get there first?
I thought you were going to fly. That's not fair to
I'm going to fly there at the same rate that they're going to walk. Who's going to get there first?
Well, if you...
I'm going a less distance, but I'm going to be moving at the same rate, so therefore it's going to take me less time to do so, right? It's common sense. If you go the same speed, but you're going less distance, you should get there faster. It'd be the same thing if one of you was going to walk to Beaver to go get lunch, and the other person's going to walk to Subway and get lunch. Who's going to get there first? Subway, right? So it's shorter distance, so therefore it's going to take less time. All right, so this is how you can find distance and displacement. To introduce your homework,
Oh, what?
we're going to do a brief, this is to introduce it so that you know what we're doing roughly. We're going to do a brief example. What?
I'm gonna
Oh, 7
It's like a kite.
Yeah, it's kind of crooked, but yeah, could be a kite. It would be not a rhombus because the sides are not all equal.
That would be trapezoid.
It is not a trapezoid because none of the sides are parallel. You'd have to have one set of parallel sides.
Quadrilateral.
It is a quadrilateral. That's your general broad heading. So it's quadrilateral, it's not a parallelogram, which means it can't be anything behind or below a parallelogram. And it's not a kite, because these are not perpendicular in the middle.
That's awesome.
But anyways, you know, math aside, what we're going to do is we're actually going to determine distances and displacements based on locations that we're going to go. So I'm going to ask you, what is your distance and displacement for the following locations? Okay? So as an example, let's say we're traveling from A to C to D. And my question is, what is your distance and your displacement? So don't shout it out, but see if you guys can determine it.
What would it be?
We're just not using B.
AC. ACD. Where's the other C?
All right. Did you guys figure it out?
You didn't even know it was time. It's all about time.
So your distance traveled going from A to C to D.
51.
So you're going from A to C, and then from C to D. So it's 30 miles plus 21 miles, which is
51.
51 miles. Very good. How about your displacement? Displacement, you are going directly from your start to your finish. Where did we start? Where did we finish? So we're just going from A to D. What's A to D?
22.
22 miles.
Is that line like from the same line as a 30 miles, but like once you go through the left, the line's like, is that still part
It's
of the 30?
yeah, the 30 is all the way across.
Oh, okay.
Because if this is 23 and this is 16, that's 39, which means that I had to make it pretty long. So
Okay.
the 30 is the whole way across. I just didn't want to split it up across the middle. Good question. All right, so it's 22 miles, but I'm not done. What has to be added for displacement? A direction. It's a vector quantity. So what direction are we going to make it?
North.
It's from A
South.
to
South.
D.
Southwest.
There you go. Good. Going on an airplane. That is how I want to see your distances and your displacements. Your distances on your homework, I actually want to see all the math. So I want to see the numbers that you're adding up just to make sure that you did write the correct numbers down. Okay? Which we'll do in a little bit. All right, one more here, and then we'll go through and get to the homework.
Yes. Oh no.
What?
I gotta write it all over again.
All right, B to C to D to A to B. McDab. Wasn't that funny, but all right, I'll take it. Okay. So, B to C to D to A to B. Starting out B to C is how far?
16.
16 miles. B to C. And then from C to D, it's 21 plus 16, which we are now at
37.
37. Good. So now we're at the D. D to A, 37 plus 22.
59.
59. And then from A all the way back to B.
72.
So 59 plus 23.
72.
82.
80.
82 miles. Okay.
I'll need the attitude.
I'm just past
What's my displacement? 0. Very good.
Oh.
Do I have a direction?
No.
Nope. If I'm not going anywhere,
What?
I don't need a direction. All right. Yes.
West,
What if you're in,
southeast.
like, is it different if you're in space because there's like Are there cardinal directions in space?
You wouldn't use a cardinal direction, but you could say left, right, or towards or away from an object.
It's like X, Y, and Z.
You could do that too, but you just gotta have a reference point. Exactly.
So you just have that one point of reference.
Yeah.
Like the sun. You're looking at the sun.
Yeah, and you'd have to say, all right, I'm going towards or away from the sun, and then you'd have to say, all right, that's going to be my positive y-axis, so this is going to be my positive x.
Got it.
So you have to define it. Yeah,
Good question.
it does. So if I was doing displacement in, say, space, but this one, since it actually doesn't have a magnitude, there wouldn't be a direction with it. This is like the only time it wouldn't have a direction. So if a vector is 0, then it doesn't have direction. All right, so fun fact. Let's say you guys were born in a hospital,
Right.
I was born in the back, yeah.
Alright.
okay?
Backseat, but close enough.
And then you went through your life and everything, and then later that hospital made some renovations, and the maternity ward ended up becoming the hospice care. Okay, so then you're ending your life, and you're placed in hospice care, and you're actually in the same room, in the same bed, and everything that you were born in.
Oh my god.
Guess what?
Oh
Oh.
my god, you gotta start from the
You went nowhere in life.
Your life had
Your life had no direction.
no.
Simply stealing all my jokes, but it's fun, right? Okay, just wait till chapter 7. Oh, it's gonna get worse. Okay, so go ahead and take your homework out now. You're gonna look at the back page first. What we're gonna be doing is we're gonna be choosing 5 locations from the map. The only stipulation, these 5 locations, we're gonna be basing it off of the country name, and I'm gonna label them based on the first letter of that name. So if you chose, say, Niger, you cannot use Niger and Nigeria because they both start with an N. Okay? Alright, so you're choosing 5 locations.
Wait, and they can't start with the same letter?
They cannot start with the same letter, but we're doing it as a class, so don't go and like just around.
Egypt.
Egypt, okay, so we're gonna start with Egypt. I'm gonna put my dots on the capitals. So I'm gonna label this as E.
Somalia.
We should do this.
Okay, so yes, this is your homework. You're creating your homework right now. Somalia,
Where's that at?
West Coast, right there.
Congo.
This is
Wait, okay, you can't pick everything.
Yeah, you're not picking. Okay, what else?
Go to the try.
Somebody who hasn't picked one yet.
Huh?
Botswana.
Where's that at?
Dude,
It's in the
bro,
bottom.
it's like freaking
The
long.
bottom.
Okay.
Botswana.
Haha. Okay. Well, if you're talking about that, you
Wait,
pick
isn't that the
Djibouti.
East Coast?
Djibouti.
Isn't that the East?
But that's too close. Oh yeah, because we're on the other side. You're right. Yeah.
Why
thanks.
did you say
Morocco.
Don't worry about it.
Making
Morocco.
Crazy.
Wait.
Where am I looking? There. I was like, it's up top somewhere.
Uh,
Okay.
Where is
Up top.
Morocco.
On the west coast.
There we go.
Yeah. All right. Pick somewhere. Pick somewhere in here.
Ga-
How about Ghana?
Gabon.
Ghana. So we have MESBE. Yeah. Okay, that'll work. So Ghana.
Wait, I'm.
Ghana's right here. Right in the trigger. Right? Because, you know, Africa's like a gun facing downward, so it's the trigger area. It's usually how it's defined.
I've never heard of
That is 5.
Like that
So
before.
we got our 5. All right. What I want you guys to do,
Do you want us to do like a
connect the dots.
any way we
I want 4 lines coming from each dot. You're connecting them all to each other, making like a web.
Can I
Okay?
get a ruler?
Yes, I have rulers.
Wait.
Question.
Outside, like every single one has to like. Do they?
Each one is connected to each other one. So you can have 4 lines coming in and out of each one.
Dude.
Well, you'll see.
Is it, wait, hold on.
So
Is there an
No
A,
more
B, C, D,
questions.
or are we gonna make up ourselves?
They are. No, I'm gonna make those for you. Yep. All right. So I am connecting. What do I use? Blue. M to E. And I'm connecting G to M.
One, two, three, now we got it.
yours is a lot nicer than the other class because the other class was all jumbled at different spots. It's good.
Mr. Schmidt, we're gonna say you make very good lines.
Thanks. I have to.
Oh.
Are you gonna make us go research the distance between these cities?
That was like perfect, man.
What's gonna stand
There's
out?
like a bird and a hen.
Okay. We ready? Because what I'm gonna do now is I'm gonna put in your.
We have, I thought you said it has to go to one and another.
Yeah. Did I do? Oh, I missed one, didn't I? Ah, I did.
Whoa, what's going on here?
There's not 4 coming out of M.
I got it.
Okay.
Okay.
They're all clear.
I know. Oh my gosh, you guys are critics.
Oh, it's a star.
I don't know if you knew
I'm
this, but
so
we got ours.
Okay.
Do you?
Yeah.
No
Can't
way.
make them black.
How about that? Black?
I don't know. I just can't see.
Well, they look the same as yours, don't they?
No.
No.
It's a star.
Oh, I like mine.
Oh
That's very
my
good.
God.
It probably is. That's really.
It's not that way.
I just keep forgetting. I like it.
Better?
Much.
Yeah, you're stronger. Okay.
Alright. Anyways, let's begin. So what I'm going to do is I'm going to pick different locations so that I have distances that are accurate. So let's see. Yes, you have 5 outside, so therefore it's going to make a star.
I think I did it.
Wait, let's see. Oh, and then I hit you. Oh, pretty loud. I didn't know.
Alright, so the... What's that?
There's like a house on the other side. I thought you were gonna do
Oh,
it.
that's
We were
cute.
gonna hit you.
You
Never
guys,
mind.
let's go.
That was really good.
Okay, ready? So this is going to be...
Dude,
5,000 kilometers.
Oh, that's a lot.
At least I didn't put it in meters.
Well, thanks.
Uh-huh. Okay. So we'll make this 6,000 kilometers from Ghana to Egypt.
Yeah.
Okay, Ghana to Egypt, 6,000. And once again, Botswana to Somalia is 5,000. All right.
Yes.
We'll make
Egypt to Morocco, 3,000.
0.5. That's 4,000.
Yep.
I called it.
4,500 kilometers from Ghana to Morocco, or vice versa. And going across the middle. $7,500 kilometers from Ghana to Somalia.
Somalia. I know Somalia. Oh, I said that one. You said 7,500?
Uh-huh. 6,500 kilometers from Ghana to Botswana. Do the edges here.
Bless you. Bless you.
Thank you.
You're welcome.
Just to have a different number, we'll have 4,000 kilometers from Egypt to Somalia. And these are all estimates because naturally I can't do this exact right now. At the
Mr. Smith, the distance from G to E and G to B is like the exact same.
yeah, it's pretty close. Did you measure with a ruler?
Yeah.
Which is fine. I just wanted some different numbers, just so they're not the same, so I can easily distinguish them. So yeah, it's probably not going to be accurate, but it helps me visually see it. All right. We'll say that it's a calm, cool 1,000 from Morocco to Botswana. Or not that 1,000, sorry, 10,000. 10,000. My bad. You only had to add one more zero. It's all good. So 10,000 kilometers from Morocco to Botswana. See across the top. Let's make this. I already did a 5,000. Make it 5,500 from Morocco to Egypt. And that leaves me with what? 2 more?
Yep.
Yeah.
Okay. Morocco to
Egypt
Somalia.
to
8,000.
Let's make this. No, 9,000. Wait. Yeah. No, more than that. 55. Yeah. We'll do 9,500. So 9,500 kilometers from Morocco to Somalia. And the last one, Egypt and Botswana. We'll do 8,500. Why not?
Why not? Just do it.
All right, so you have all those now, right?
Yep.
Okay, so here's what's going to happen. I'm now going to create the different paths that you're going to take. So go ahead and flip your page over. And for each of them, we are going to write some letters with arrows. I will put this on the next slide, so you'll be able to see. I'll write them all down for you so you can copy in case you miss one. But our letters that we have are, let's see, we have an M, an E, a G, an S, and a B. All right, you ready?
Oh shoot, you weren't saying that order.
No,
Sorry.
it's all good.
Next.
So we are going to start out going from B to E to G.
That's all.
Makes it easy, right? You can remember it. That's the first one.
Bag.
B to E to G.
Bag.
Beg me for a better choice. All right, the next one. We're going to go from G to E to M to S.
Gems.
Look
Are
at
you doing this on
that.
purpose?
Why not?
Okay.
You guys came up with the letters. We're just doing anagrams now, right?
Yeah.
Okay, no more anagrams. All right, we're doing M
You could do Meg.
to S
Okay.
to G
Madison Square Garden.
to B. Somebody's got Chinese on the brain. To E. So MSGBE. It's Ms. Jabi. All right, number 4. We are going to go from S to M to E to M to G to S. Smen's. Okay, and the last one, we're going to start out at E. E. The letter E. As in excellent. As in elephant. As in earwig.
As an air.
What's an earwig?
Pincher bugs.
I like
Why they say air?
So E to G. Can't do another G. No, we're already there then. That's not helpful. E to G. And then G to...
S.
That's pretty much going... Yeah, that works. S, because we haven't really done that a lot.
Eggs.
Okay.
Eczema. What about that video? Eczema.
To M. So E to G to S to M. To B.
To be or not to be.
And then to S.
S.
And then back to M.
Okay, can I have to reset that E?
And then you should go back to E. Do back to E.
Okay. All right, so to make sure you got them all correct, number 1, we are going
Beg.
Number 2, we are going. Number 3. Number 4.
Shake my
And number 5.
F you, mother, God's. Eggs.
Okay, got it?
Get eggs. Eggs.